Welcome to another stair building education series. Let's go ahead and jump right into it with our first video. In this video, I will provide you with another project that you might be able to build without a lot of complicated math or calculations. And we're simply going to have a deck with 3 steps. And the beauty of this is that you're going to be able to use 2x6 or 2x8. However, with this design, we might have a problem with the building code that requires a 4-inch sphere or a round ball to not be allowed to travel through any part of the stairway. And we're going to be at 4 inches here. If I have a 2x6 and then I put an 1.5 inch thick decking board on top of that, I'm going to be right at 4 inches. And if I use 2x8 for something like this, I'm going to be over 4 inches. And I'm also creating this design here to sit on top of soil. And I'm not about to suggest that these bottom boards won't rot. And I will leave it up to you if you need to make further modifications to this to meet local building codes or work in your area. Another good thing about this design is that we are not going to have any mitered corners. Everything is going to be a 90-degree angle. And that's going to make this project a lot easier to build also. And to calculate the lengths of the boards we're going to use for the smaller stringers, all we need to do is draw a straight line down here and then measure each one of the boards from that straight line. And that's going to give us the length of each board for these smaller stringers. So in other words, this board right here will be the same length as this board. This board here going back to the line will be the same as this one here. And I know that might seem confusing, but let's go ahead and motor on and continue with our tour here. Don't forget you can stop the video at any time. And of course, watch the video again if you miss something or if something isn't quite making sense. And don't forget that you can modify this design, like I mentioned earlier, by installing additional bracing, blocking, and structural supports. And you can connect each one of the 2x6s together with building hardware like straps or flat framing anchors, even blocks. Just make sure that you install some of these framing anchors on each side. If I was just going to install all of these framing anchors on this side, along with the straps, then it might allow the 2x6s to fold over at the breaks or where the 2x6s are going to be connecting to the other 2x6s. So we're going to need to install some type of support bracing on both sides. And another idea might be to use a block. And if you put the block in between 2 boards here and then attach it with screws or nails, something like this here on both sides, then you might be able to use that instead of something like this. And you might even be able to use dowels to fasten these together. And don't forget to check out other types of framing hardware that you can use to create stronger stair stringers. And to figure out this length here, we're simply going to lay out some of our decking boards until we get the desired width that we want. If you want to cut one of these in half or cut it down to create a specific shape, then go ahead and do that. I'm not doing that. This deck, to meet most building codes, needs to be 36 inches long or 36 inches wide here. And to get that, I think 36 inches is right about here. I made it a little bit longer. You can't make it shorter, but you can make it longer. And if we use this method here, we're going to be able to create a deck that doesn't have shorter boards in it. Our deck's going to look nicer, at least in my opinion. And we're going to do the same thing with our stair steps. 2 steps with a 2x6 is going to give us about an 11-inch wide step. And it's going to be important to keep all of our stair steps the same width or depth going in both directions. So if you can see here, we're just simply raising this step up here. And I'm going to do the same thing with this step here. And finally with our last step here. If you notice, I've created a flat section here. And we're going to use each section here to calculate the lengths of our decking and stringer boards. And this is the beauty of this right here. This really makes your job easy. And make sure that you figure out the width and the depth of the deck before you get started. So in other words, you might not need to cut any of these boards For example, if I had 10-foot 2x6, I could lay the 10-foot 2x6 next to each other, put the desired gap in between each board if I'm going to have a gap in between each board, and then grab my measuring tape and measure the distance. And if I want to make this distance here the same as this distance here, so that both the width and the length or the depth of the deck will be the same size, then I can do that. And it wouldn't be that difficult to lay out your boards in this direction here with the desired gaps if you're going to have them, and have them run full length to get these measurements here. So the measurement for this board right here is going to be the measurement from right here to right here. The measurement for this board right here, this step, this 2x6, the second one down, is going to be measured from right here to right here. And this board here is going to be the measurement from the front of this right here all the way to the back. And you guessed it, this measurement here all the way from this point to this point is going to be the measurement of our bottom board. And now would be a good time to point out that the bottom board will need to be ripped down and made a little bit shorter. What you're going to do is take the height of the decking. 2x6, we're going to have 1.5 inches thick 2x6. We're going to subtract 1.5 inches off of the bottom board. So if we have a 5.5 inch wide 2x6, we're going to rip that down to where it's 4 inches wide. And that's going to allow you to make each riser height the same size. So again, these lower boards, all of them are going to be 1.5 inches shorter if we're using 1.5 inch decking. If I'm using 2-inch thick decking, then I'm going to subtract 2 inches off of my 2x6. And I won't be going into a lot of detail about that in this video. However, I do have plenty of other videos at our website. Make sure you check them out if that doesn't make sense. And in our design here, these are not going to be the same size because the width of this is shorter than the length. And you can see it right here. If I wanted to make this length here the same as this length here, then I would need to cut these boards a little shorter. For example, if I have 3 foot 3¼ inches as a measurement from here to here, I've figured out how many decking boards I'm going to need according to my local building code. Got to be bigger than 3 foot. Then the same is going to hold true for the width. I could simply cut these boards here 3 foot 3¼ inches to create a square landing, or a landing with the same measurement for the width as it would be for the depth. And that's going to change the measurement of some of our boards. And I could always make this 4 foot wide and this 4 foot long also, if it's going to work with our decking. Here's a project I ran across and thought it might be helpful for handrails and concrete stairs. And you can see right here, this right here would be a very weak handrail. It's really nothing stabilizing it. And thought that it might be better if we actually bolt the post onto the outside. All this would require would be some anchor bolts embedded into the concrete to stabilize the posts. And you can see right here that we have a 4x4 post and 1 anchor bolt. This has a flat washer. You can use round washers, as you'll see later on in the video. Make sure that you hold the post off of the ground. Make sure that it's not touching the concrete. 1/4 inch would be fine. And if you do, make sure that you clean it every once in a while. It's common. I've seen people take these off the ground 3/4 inch, and eventually you've got a pile of leaves and dirt, and the wood post is starting to rot. So keep that in mind. Wanted to give you an idea what it would look like with the anchor bolt into the concrete. You might need a longer anchor bolt, a 14-inch anchor bolt, not a 6-inch anchor bolt. I'd go with a little longer one. And then make sure that the anchor bolt, the J-bolt part of it, is turned in. Either turn it in or turn it down, but don't have it going out to the front. It's going to be a little bit stronger if it's the more that this section is embedded into the concrete. And you can do the same thing with a post up here and run them around your stairway. You can use 2 bolts instead of 1. You can always make this one a little longer and full length. And this is just going to provide you with a little more support. Something like this, 1 bolt might do, but 2 bolts might do a little bit better. Here's an example of what it would look like if you had a square washer notched into the post. How you accomplish this, I will leave that up to you, probably with a router. Could do it with a chisel. Here's a round washer on the outside of a post, and here's what the round washer would look like countersunk into the post. And of course you could do this with a larger drill bit. Another thing you might want to do is cut the threads off. I see this a lot. You'll see patios built and the threads are the threaded part of the anchor bolt is sticking out 2 inches. This is going to snag someone's clothes or even hurt somebody. Keep in mind that most building codes do require to see at least 2 of the threads visible on the anchor bolt. So you can't cut the anchor bolt flush with the nut. Give it about 1/4 of an inch or 1/2 inch depending upon what size anchor bolt you're using. Wanted to pull away here and give you an idea of what the post might look like if you're going to be going around a concrete stairway with a landing. You might not be able to put a post in the corner. It might require 2 posts like this. You know, if we were to take the corner here and line it up with this corner here, how would you bolt it to the concrete? So that'd be something to think about. And here's what it would look like on the other side. And here's what the anchor bolts would look like. Just wanted to give you another view of it here. Sometimes it's hard to imagine what the anchor bolts would look like, how they actually work. And there it is. Now, it wouldn't be a bad idea to install some type of a membrane, maybe roofing paper, window flashing paper, or even a sheet metal, galvanized metal, in between the post and the concrete. But that would all depend upon how much moisture you actually get in your area. You know, if you live in a wet climate where it rains a lot or you have snow sitting on the ground for a while, you might want something between the post and the concrete to prevent the moisture that gets absorbed in the concrete from absorbing into the wood. You live in a drier climate, the desert, this might not be necessary. This is part 2 to a video that I made. I will put the name and a link to that video in the video description box. And I think I figured out a way to have both what I would like to see, which is something like this, and the design you're going to see here in a few seconds. For those of you who believe that this design right here won't work for you because somehow the stringers are going to slide forward even though they're nailed and securely fastened to some base framing plates that are securely fastened to the concrete, or base framing plates that would be securely fastened to a wood-framed floor. Because either you or the architect think that this is a superior design. I cannot see it. I'm never going to see it, and I'm never going to agree to it, even though I saw this design on almost every set of building plans I worked with. I never used it. I never used it. My dad never used it. And there's no way I'm ever planning on using it because it just doesn't make sense. And the reasons for that can be found in the other video. For those of you who just want a brief explanation, a lot of it has to do with making this notch here and then fastening the stringers to this plate here. And in some cases, I've seen a gap here, and I don't like the gaps. The gaps can cause the stringers to break. And something like this might work fine on a wood-framed floor where you can drive more fasteners through the stringers into the wood-framed floors, or even use framing hardware, where on a concrete slab, you can see where you're only going to be able to attach it to the base framing plate, not to 2 base framing plates like you would have seen in the previous example. So what about this design here? Is this something that might work better for you? You're going to get both of the framing plates, which is what I would like to see, plus a couple of notches that in your mind might prevent the stairs from sliding forward, even though these notches wouldn't be necessary if the stringers are securely fastened to the base framing plate. So something like this would make me happy and make those of you happy who believe that this notch right here is somehow going to work better than the very first example I provided in the video. And if that one seems like too much work, what about this one here? Install the framing plates like I would like to see them installed and have a notch at the back of the stringer, providing us with another method that might work better than the second example in the video. You're going to be able to use two framing plates that you can use to attach the stringers securely to the foundation and have your notch here to prevent the stairs from sliding forward, if this is actually something you believe will happen. Again, even though I've never seen it happen. And if you don't like that idea, what about this one here? Grab a huge piece of lumber and securely anchor it to the foundation. Don't just secure it in the front or in the back. Otherwise, you could end up with the board twisting and forcing one side of the stringer up, and that's probably not going to happen if you have enough base framing anchors to prevent that from happening. In this video, I am going to provide you with a few examples of different designs, different patterns you can use for stair treads when you are going to be using brick. And the bricks would be a standard brick, 3 5/8 by 2 1/4 by 8 inches long, 3 5/8 wide, and 2 inches deep, 2 inches high, we can say. So this would be 2 inches. And here we have the bricks on their edge. Here's another one here. We just reversed this one. This is actually one of the most common designs here. This one here used, and that's because it really gives you a heavy duty edge if you are going to have a nosing. If you are going to have risers that are even flush with the front of the stair tread, then any design in here will work fine. If you're going to have a nosing an inch or something like that, where this will protrude past an inch, past the riser, then this is by far the best and the most common, I would say, used by bricklayers. So this one here wouldn't be as good, but I threw it in there. I just kind of reversed this design. I reversed this design too. This one here would work a lot better than this one, but both of these will work just fine if you are going to have square risers that are even with the edge of the brick. The reason why I'm saying that is so sometimes you're going to put pressure on the edges of the bricks, and if they're like this, where they're not going back into the step, let's say, very, very far, they can actually just pop right out. And I've seen that happen before. Brick just come right out. So anyway, this is these are a couple designs here. Here are a few more. Just different things. I reversed this one. This one here would I would like to see if you were using a nosing. These right here would work fine if you weren't going to use a nosing. And you can see here where this one is just reversed. I can't reverse this one. This would give you the same exact pattern. Can't reverse these either. You're going to get the same pattern. Another view of it there. Couple of more and different designs. This is just reversed, and of course this one here is not reversed. We just have I staggered the bricks in the back. You can see where this lines up here, and this one here does not. So this one doesn't line up, but this one here does. This is it for our stair treads. Let's go ahead and take a look at the risers. Here are a few examples of some risers. This is probably the most common one you're going to run into. There's just another design pattern here. This one here might work well with the treads where the bricks are on edge. Another design here. And this, I just ran a brick this way and then ran one this way, and kind of gave you this pattern. This one here, we just kind of moved it over a little bit and to give you a different pattern. And you can move it the other way to give you a different pattern, or move it just a little bit. You can get pretty creative with the bricks. And I used a full brick here. You could always cut a brick in half. A lot of masons wouldn't do something like this. They would just get their little cutting tool and whack it real hard and split this brick in half and use it for the front. These bricks are going to be on edge here, and I believe the total height on this one is almost the same as the other one. This one here is 4 3/8, where these here, this one, this one, this one, and this one are 4 3/4, I believe. And this one here is 2 3/4, and that would be with a 3/4 inch spacing for the grout. And let's take a look at what the treads and risers would look like together. This one here, we have a riser that's even with the front of the tread. This one here, it is set back, creating a nosing. We can see here, this is even. This one here is has a nosing on it. This is, these were here, we're using flat bricks. Let's go back here. These bricks are on edge, you can see. The 2 inches is this way instead of, or vertical, I should say, instead of horizontal, if that's right, or horizontal and vertical, reverse it there. And of course, this one here has a nosing on it as well. So I just wanted to give you an idea of a few patterns. I am going to try and put together a few more videos. I'll put some links here, links to the videos at the end of the video when they are completed. But thought this would be helpful for anyone who is going to be building some stairs in the future or designing some. And you can get pretty creative with these bricks. I have seen some fantastic designs. My only concern, and I cannot stress this enough, is to make sure that you use a brick to where the longest part of the brick is actually going back into the riser or into the step, if you are going to put a nosing on it. If you are not going to put a nosing on it, it won't really matter. But if you do, I shouldn't say that, but if you do put a nosing on it, you can see where any pressure here applied here, like maybe someone's pulling a refrigerator up a dolly. You're using the stairs, you're going up. You can put a lot of pressure on this and actually pop the brick out. The smaller it is, the more the chances of it would be of popping out. And I do have to say one more thing. Bricks do take a beating. I have seen them get pretty beat up over time. And matter of fact, I'm going to go ahead and put some pictures in at the end of the video here of some brick stairways that I took some pictures of to complete the video. I don't know how old this particular brick stairway is, but you can see where the damage has been done, and it is worn around the edges. So this one here looks like it's missing a big piece here. And some of these, I hate to say it, some of these could have actually been built that way. You could actually have a problem with, this something like this. Maybe it was built this way. More than likely, it was built like this. But I have seen plenty of bricks where they are worn on the edges. But you can see right here again, it's just a little bit of wear and tear here, and not really on the bottom. This is rounded. This one here looks a little square or flat. A longer stairway. This one doesn't look too bad. Again, I don't know how old they are. Here's an example where the bricks are running this way. And like I said, with a nosing, something like this could actually pop out. And it doesn't look like, I'm looking at this stairway, I don't see any problem. Sometimes you'll see where they've replaced the grout is a different color, or the mortar here is a different color where they went in and replaced a brick. And I'm not really seeing that here. So, when I say that, it's a concern of mine, but it might not be a concern of yours or a mason. Thinner bricks, pavers, I don't really recommend using them. But this particular stairway, I'm guessing, is pretty old. But again, I don't know. This doesn't look like a common design here. You can see where the nosing, the bricks are a little longer. I don't know if you can even purchase something like that. Same type of stair design, rounded treads. Now, the rounded bullnose, that's pretty common for stairs. You can always use those for your bricks also. Water, I think I was just going to show that in there, so the water damage. In this video, we're going to go over how to lay out the stringers in the unsupported part of the book. This would be the bottom of the landing, and probably just providing you with an example of something to think about when you're laying out the stair stringers of something that you might not want to do. And that would be to lay out a stair stringer and use some type of it'd be nice to have a hanger or something that that will support the bottom of the stair stringer. In these two examples here, the stair stringer might not be supported as well. So we can't just draw a straight line and expect to nail the stair stringer into something. It's not going to be supported very well. The nails or the screws could loosen up. So something like this isn't always going to be the best idea. And then thinking about, marking something even with the joist 5.5 inches, whatever the joist size would be, and then squaring it off without the general understanding of how it's going to be supported again. Most joist hangers that you'd be using to support a stair stringer, I don't think they're over 2 inches wide. So in this case right here, I believe it's about 3 inches. So you are going to have a certain section of the stair stringer that wouldn't be supported. And if that's the case and it actually cracked there, it could severely weaken the stair stringer. Here is the second video in our adding a crawl space addition to a house that already has a crawl space. So this would be adding a 16-foot by 12-foot home addition. And keep in mind that even though I will be providing you with certain lumber, for example 2x4 sill plates here, I will not be able to provide you with any structural engineering lumber sizes because of all of the variables all around the world. And these videos are watched in most English-speaking areas. And even I find it hard to believe sometimes what countries are watching these videos. So with that said, let's go ahead and get started and take a look at our anchor bolts. Remember, the anchor bolts need to be within 12 inches from the outside of the plate. And of course, that would be in this direction and then from here over. And we are going to be using treated lumber for our sills, along with a ledger, and the ledger will be the same size as our joist and will be attached with hangers. You can always do this a different way. You don't need the hangers. You can have the joist sitting on top of the plates here or run the joist in the other direction. Now, I wouldn't recommend running the joist in this direction because this is 16 feet long. It might require larger joist, where in the opposite direction it's going to be 12 feet. And if you noticed, I drilled a ventilation hole here. And you don't have to do this. It could actually create problems for your insulation on the other side or the insulation on this side. And if there is enough ventilation on both sides of the building, on the existing floor and on the new floor, then you might not even need to do something like this. And this was the original crawl space vent that would have been removed and then a new slot cut in so that air could transfer between the existing building and the new home addition floor space. And you could always cut additional vents like this in if you needed to, but this is where drilling holes might work out better. And of course, I made this a little longer over here so that we could nail the hanger onto it. So that might be something else for you to think about when you are laying everything out and cutting or drilling any holes into the ledger or the rim joists on the other side. So not too difficult. Put our hanger hangers on, install our joist. And if you notice I don't have a hanger here, you can always use an inverted hanger, no problem. Or just simply nail it into the rim joist and let the cantilever here pick up the weight. Or even this would be a good situation where you could stop the ledger here and then cut the existing rim joist back so that these joists can sit on top of the framing plate here. So keep that in mind as another option. And of course we have our new crawl space vents. And even though I have 3 in this example, you might need to install more or less. So not too difficult to install the joist here. And of course the joists are going to be 16 inches on center. And another thing you might need to do will be to notch out part of the rim where it could be meeting these heavy duty washers. So that would just be a simple notch here so that the rim will sit on top of the framing plate. And for those of you, if you haven't noticed, I moved these over instead of centering them on the 2x4. And this is something else. You could always use 2x6 and then center these in the 2x6, and then the rim joist won't be in the way of these large washers. And you might need to re-watch the video, or at least the beginning of the video, to get an idea of where these are located, or you can see where they are at least not centered. Next up, let's go ahead and install our first piece of sheathing, and we are going to be using 4x8 tongue and groove, and we will be lining it up with the edge of the joist on the outside and the joist on this side. However, I am going to provide this example of what it would look like before cutting the tongue off of this side, and I will provide you with another example at the end of the video of what it would look like with the tongue cut off. And make sure that you lay out the floor joist so that you won't need to cut the sheets of plywood, or at least cut as many of them. And in our example, since we are going to be using 16 feet as the width of the home edition, then this is going to work out perfect. And don't forget to install a gap between the pieces of plywood or OSB, and that's usually going to be about 1/8 of an inch. But you might want to read the installation instructions from the product manufacturer. That's always a good thing, right? So 2 pieces of OSB, let's go ahead and put in our third one. And of course, this is going to break at the center of each one of these boards. And we will cut 2 4-footers for the outside and then repeat the process for these last 2 pieces. So this would be a structural engineer's dream to see something like this and have everything fit into place. So the tongue and groove usually works like this. And of course, the engineer would like to see the tongue sliding into the groove here to where it looks something like this. And if you don't use tongue and groove materials, then you might need to block. That would be to install blocks in the joist at these plywood breaks. And I am pretty sure I have already made a video on that if I want to check it out at the website. And the most important thing will be to make sure that the top of the floor on the room addition lines up with the top of the floor on the existing house. And if any of the materials are going to be different on this side, then you might need to make the adjustments before you pour the concrete foundation, and even better, before you start to form the concrete foundation. So with our floor sheeted, let's go ahead and take a look at the tongue that we have removed here. And I wanted to provide you with 2 examples. This one here is what most of us are going to do, and that would be to cut the tongue off to create a square edge here. However, that might not work out for your sheathing. And if you need to, you can always leave the tongue on here and move the plywood over just a little bit, especially if you need an additional 1/8 of an inch, 1/4 of an inch, or even a 1/2 inch on the other side. So don't rule out this as an option, because sometimes it's going to save you some frustration. Now, I showed you this right here, starting from this end here. However, you could always start from this end and install these 2 sheets first, and then this row, and then this row. And I know a lot of people are like, well, this is where I would start. Well, so other people are going to say, I want to start on the straight, and I know this is straight. I just built it. However, you could always snap a straight line across here and use that as a straight edge, and even do any modifications you need to these pieces of plywood. Just keep in mind, like I said, if you start cutting a 1/2 inch or an inch out of something, that you're not going to end up with a small strip over here that the engineer isn't going to appreciate. So let's go ahead and wrap the video up. This is it for the floor framing, and in the next video I will have the wall framing and possibly the roof framing also in one video. If not, then I'll break them up into 2 videos. It all depends on how much I have to say. I was going to have the wall framing in with this video here, but it just didn't work out.